Alright guys, in this video we're going to be discussing asymptotes and in behaviors. An asymptote is a boundary line that a function approaches but never crosses or touches. Exponential functions have asymptotes. Linear functions do not. That's important to remember. Alright. If f of x equals ab to the x, the asymptote is always x. Is always the x-axis, or y equals 0. So the x-axis will always be the asymptote if you just have a normal exponential function. And f of x equals ab to the x plus k, the asymptote is y equals k. So right here in a normal function, before you add your k value over here, whatever that number may be, your a value here is your y-intercept, and your b is your rate of change. Or your and your x and your y are just your x and y, and then your k can affect your y-intercept, and it's also your asymptote. In behavior. In behavior describes what is happening to the range of a function as the domain increases and decreases. To determine in behavior, look at the left end and right end of the function. The left represents the decreasing x values, and the right end represents the increasing values. So in behavior, it's similar to domain and range, but everything is keyed off of your decreasing or increasing x values. Steps. Look at the left end of the function graph. Determine what is happening to the y values. Describe what is happening to the y by saying the y values are approaching positive infinity, negative infinity, or the asymptote. Describe the end behavior. Alright. As x decreases, y approaches positive infinity. Now, this is just an example of something you might write. Or as x increases, y approaches the toad 1. At 1. Alright. Create a table of values for the exponential function f of x equals 2 to the x power plus 4. Identify the asymptote and the y-intercept of the function. Find the points and sketch the graph of the function and describe the end behavior. Alright. So we have our XY table over here. Notice we started -4. So we'll look at our tables. I plug in -4, and that's our X value. So you can plug this in your calculator. I showed y'all how to do this. Or you can make the actual table where you're plugging in the X values. Notice wherever X is 0, that's my Y-intercept. Alright, notice that my asymptote here is going to be 4. If you look at your graph, you'll see your horizontal asymptote, and your asymptote equation here will be y equals 4, because that's where it crosses the y-axis at. And you notice right here you have your y-intercept. Alright, and then you also notice as x decreases, so that's telling us as x goes left, the y is approaching the asymptote at 7. So you know our asymptote right here, oh, excuse me, not 7, but 4, is approaching 4. So that as x decreases, the y is approaching the asymptote 4. So that is the end behavior of that end of my graph. Now, as x increases, so as x is increasing here, y is approaching positive infinity. And remember, we label our graphs, so we know positive infinity is going up. So as my x values are increasing, the y value, or the range, is going up. Alright, determine the asymptote and end behavior. Alright, asymptote. We learned earlier on linear graphs you have no asymptote. Alright, and then especially on linear graphs we want to label our infinities here. So as x decreases, so as x is decreasing, then you see our line is increasing here, so that means it is approaching positive infinity. And as x increases, the y approaches, so as x is increasing, our y values here are approaching negative infinity, and we really don't even need our x infinities. Alright, and so the line's going down as x is increasing, so it's approaching negative infinity. Alright, determine the asymptote of the function. Remember, the asymptote is always the k, so our k value here is -3. Alright. Right here, we don't have a k out here, so there's nothing out here, so therefore our asymptote will be 0. And now you may also see the asymptote equation is y equals -3, and this will be y equals 0. Remember, that's what it's approaching. Number 2, you look right here, our asymptote right across 0, so this one's y equals 0. Right here, you notice that's our asymptote, our end behavior. As x is decreasing, and we can label ours, y is approaching, so as x is decreasing here, you notice that our y values are going to negative infinity. As x is increasing, y is approaching 0. Alright, our next one. Alright. We see right here that it's crossing at 1, so we know our asymptote is at y equals 1. Put our positive infinity on there. We know as x is decreasing, y is approaching the asymptote of 1. So as x is decreasing, y is approaching the asymptote of 1. So as x is decreasing, asymptote at 1. And as x is increasing, it's approaching positive infinity. Alright. Linear graph again. We do not have any asymptotes on a linear graph. Now, but when x is decreasing, we're approaching positive infinity. And x is decreasing, or excuse me, x is increasing, we're approaching negative infinity. Alright. That's all. Ready to do some practice over this.